All right, now we're being super serious. Okay. Um, what we're going to do today is binomial distributions. And this is easy stuff. It's going to be all in StatCrunch here in a few minutes. But I wanted to talk about what binomial is. And y'all know Latin. It's true. Y'all know Latin. And so you can help me a little bit. Bi means what? Two. Okay, awesome. And y'all are statistics people. You've been through chapter one. You know what's going on in the Latin world. Nomial, nominal. What does that mean? Name and label. Exactly. So in my other classes, they don't know that. They just say number. And I'm like, no. Two names. Hello. Um, two labels, two outcomes is what we're going to have in this particular case. And so let me give it to you. We got true, false. So I'm going to do true, false, yes, no, cheese, no cheese. Like, let's say you go, order a hamburger and they're like, hey, do you want cheese with that? You got two options. You're either going to say yes to cheese or you're going to say no to cheese, right? So that's what we're coming down to is two options, two results, two outcomes. What the homework is going to want, though, is success and failure. And so they're going to ask, I think it's like question one or two, they're going to ask, which of these apply? It'll be that one. You click on that one on the homework. That's all you're going to have to do. But are y'all seeing the bigger side of it, right? Okay, cool. Binomial, two outcomes. Okay. Blah, 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 blah. Let me just go ahead and give you the Chad version. This N is going to be your total, and your X is going to be your successes, and what I would used to have called your selected. Okay? Bless you. So I would have called it selected if we were going to do like probability and stuff like that, but we're going to call it successes specifically here in this section. Okay. So success isn't always a good thing. I'm just going to say that. Like success, you feel like, oh, that's got to be good stuff, right? But maybe it's not. Good. Here's a question. Do you like cheese on your hamburger? No? Yes. So success for you would be no cheese. But success for you would be yes cheese. You see how it's subjective? And so when I go through some of these questions, it's going to sound kind of negative sometimes, but it's still success. Maybe. We'll see. So it says decide on what all this stuff is. Let's figure it out. So a survey was conducted. Has the economy forced you to reduce the amount of vacation this year? And 22% say they reduced vacation out of 30. Okay, so those are kind of like some numbers that we're going to use. So it says, is this binomial? They're asking you, have you reduced your vacation? You're going to say yes or no. Yeah, is that binomial? Yeah, binomial. So what would be success? And this is the thing. Success is what they're like doing a percentage on. It's what they're asking the question about. And it says that 22% say they reduced their vacation. So success is reducing your vacation. I know that sounds terrible because it is, but that's successful apparently in this particular target question. Does that make sense? It's like what they're asking you for. That's the success. Okay. Any questions on that so far? So on the next page, they have the numbers, and that's where that 30 and 22 is going to come in. So we're asking 30, and the probability was 22. So I'm going to remind you, I'm pretty sure we did this at some point maybe. Q is always 1 minus P. So 1 minus the 22. Hello. I'm glad you're here. Yeah. What would be the opposite of 22%? It's not 80 something. 78. Very good. And could we do that in like a calculator? Sure. But there you go. That's the opposite. And then X, it says, what could success be? I would say it could be that it could be 0 all the way through 30. Hello. I'm glad you're here. You can grab it. I'm sorry. You bro. Look, I like you so much because you're in 2 of my classes. Do you want my chair? You don't like the rolling chair? Oh, okay. Okay. No problem. No problem. It's cool. It's like, hey, do you like roses? And you're like, I don't like your dozen roses. So I like lilies instead. But hey, man, that's cool. Thank you. All good. All good. So let's do the next one, and it's the same kind of question. So no big deal. Big deal here. It says from past records, 26% of people who enter the store will actually make a purchase. And so is this binomial? Are they going to either make a purchase or not make a purchase? Right. So that's binomial. Cool. It says what's success? So okay, let's go through this. It says 18 people enter the store randomly. The number of people who don't make a purchase is recorded. Do you see that right here? This don't make a purchase thing being recorded. That's like your X value. That's your successes. And so when they say what's success, it's that you don't make a purchase. That doesn't sound very successful. That doesn't sound good, but that's the point, is that it's not about it feeling good or not. It's whatever the problem states. We have to just be, careful about that on the homework. That's all. What would be my total number of people I looked at? What's my N, my total? 18. Very good. What's my probability of success? Now, that's the thing. Look, and this is weird. 26 enter the store and they will make a purchase. Yep. It has to be the opposite. Yep. 74. You got it. See, that is so weird. And I have it on my notes right here. I'm going to pull it up on my notes here. You can't see it, but I wrote it down. It says annoying. It says annoying. Because it is. It's like, why do you have to make it complicated? You know what I mean? And X is going to be 0 through 18. So, like, couldn't 0 people not make a purchase? Couldn't 1 person not make a purchase? Couldn't all 18 make a purchase? I don't want to, like, write 0, 1, 2, 3. That would take forever. But you could see 0 through 18. Hello. And hello. I'm glad y'all are here. I say hello to everybody. Okay. Now it says we got a standard card deck of cards. You randomly select 3 cards without replacement. They're asking what's the probability of 2 clubs? Remember that binomial's got to be a yes, no, cheese or no cheese, success, failure. I don't really see that here as much. And let me remind you one other thing that we did not read very well. There's all this that you can read. And this is all on the homework. Like, you go to question 1 and you click these 4. Then you go to question number 2 and you click these 4. Copy, paste. But one of the things here is that all of the trials are independent. They're all they're like a fixed probability. They don't affect one another. Fixed probability. Oh, right here. Fixed probability. There it is. Okay. Basically, every time it should be the same. If I do without replacement, it means take a card, any card, and I, put it in my pocket. Take a card, any card. Didn't my probability just change? We talked about that for like a whole chapter. So no, and then simply just wonk. Okay. It makes it easy, and that's how it is on the homework. They'll have that same structure. Is it binomial? No. And then you're going to say, what's success? You would say, not binomial. It says, what are all these numbers? You're going to say, not binomial. You know what I mean? Just, you have to kind of play, what did I just do? On. Turn it back on. Oh. Whew. Okay, and it scroll. Okay, good. Literally, we almost had a disaster. I'm going to put this far away so I don't touch it again. Okay. Oh my gosh, look at that formula. Doesn't that look so cool? No way. What are we going to do instead? StatCrunch. And I'm going to show you that so many times. It makes it very easy. So they try to reword the problem here, and they say, hey, 3 cards with replacement. Now, what's the probability of all these clubs and whatever? You don't have to go and do binomial anything for this. But they say find the tree diagram. I guess I'll do the tree diagram. So this is how I started, okay? I would say we have an option, pick a card, any card, and we could either get a clubs or we can get not clubs. Once I'm here, put it back, pick a card, any card. I could get a clubs or I can get a not clubs. Or over here, I can get a clubs or a not clubs. It says 3 cards, so here we go again. I can get a clubs and then a not clubs. Clubs, not clubs. Clubs, not clubs. Clubs, not clubs. This is a tree diagram, however messy that looks. But let me try to interpret it a little bit if that's okay. You can get a clubs and then a clubs and then a clubs. All 3 clubs in a row, right? That's an option, isn't it? I can get a clubs, a not clubs, and then a clubs. I can get not clubs, not clubs, clubs. Do we need any of this, though, honestly? It says, what's the probability of just 2 cards being clubs? I don't know. I'm going to just do it my way if that's okay for a second. 2 cards. 2 cards being clubs. Couldn't I have clubs, clubs, not clubs? So that's one path. So I guess like this guy is like legit. I could do clubs, not clubs, clubs. So there's 2 clubs in this little like pathway. Not clubs, clubs, clubs. So this guy right here. And that's it. 3 out of how many total do I have here at the bottom? How many total do I have? 8. There's your answer. 3 out of 8. Did we have to do this crazy formula? No. Could I have done it a different way? Maybe. But that's good enough, honestly. That's all we have to do. Is that okay so far? Go ahead. Oh, that would be that question here, which is not binomial, which we're not doing in this section. But then we would actually have to do a lot of math, and I don't want to do that right now. So, cool. I am on page 112. 112. Yep. Very good. So it says now use the binomial thing, and I think this is a nice opening to what we need to do for binomial. So let me show you StatCrunch. I'm going to go stat, calculator, binomial right there. Stat, calculator, binomial. I'm going to write that down, okay? So this is StatCrunch. I'm going to go stat, calculator, and then binomial. Stat, calculator, binomial. I'm going to click on it. Are y'all okay with me clicking on that right there? Oh, thank you. And it gives us all this stuff, but it's really, don't be overwhelmed. This is just a bell curve is what that is. We're going to just fill in the numbers at the bottom. And so N, we have our P probability, and then they're saying that X is going to be blank with blank, and it equals a blank. So, I mean, these are the kind of boxes we're filling in. And I'm going to show you how this works. It's very simple, actually. What was the total number of cards that I was pulling here? Like, yeah, 3. Yep, 3. What's the probability of a clubs each time? Of a clubs. That's the final answer we're going to get here in a second. Like, just, so like, yeah, we have 13 clubs out of 52. Or you could say it's 1 suit out of the 4 suits, right? So I'm going to say it's a quarter of the deck. A quarter of the deck is clubs, yeah? And then I'm going to say equals, how many cards did I actually want? How many clubs did I want? It said how many clubs was I looking for? Exactly 2. So I put equals 2. And then we're done. That's all going to be done in here automatically. 0.25 equals, and then you put a 2. There you go. There's your answer, 140. Whoa, something's a little weird there. 3/8? Is 3/8 equal to that? Maybe. I haven't checked. Actually, it might actually work. Here, let me, what I'm going to do here. No, it's not. Something's a little bit wrong. What did I do wrong? Where's my 3/8? Oh. Guys, I did a small mistake. The answer is not 3/8. Yeah. I saw 3 out of the 8 outcomes down there, and I said, we're good, but they're not all the same probability. This is, okay, so this tree diagram was so cool. Just ignore this, and there's your answer. And I was wrong in my workbook. I'm so sorry. So, yeah, well, this is not on the homework, thankfully. As far as I remember, it's not on there. They were just trying to be funny, and apparently I totally messed it up. So without going too deep into all this, let me real quick change this on my workbook here. Okay. And I'm going to change this, and we don't ever see that again. Okay, cool. Here's the thing. I messed up. This picture is fine, but the probability of a club is how much? A quarter? I just said that, right? A quarter times of this and of that. But then what's the probability of a not club? Right? It's the 3/4, the opposite, right? Yeah. So then I've got this one here would be 1/4, and then this guy is a 75%, and then I got another 25%, and then I have to add all those up. It takes way too long. We don't need to do that. Just use your calculator here, okay, guys? So it was trying to be funny and say, hey, look, ha ha ha, but really it was just calculator. I'm sorry for me in the workbook. We didn't work out very well. There's all your numbers. See, told you. Can I go to the next question? That's gonna be way better. Okay, this is a great question, and we're just gonna toss it in and have a great time with this. Okay. So yeah, I'm sorry. I didn't look at it correctly. Okay. So the results say that 71% of people have more than one topping on their hot dog. What are you talking about? Come on, guys. Do you want more than one topping on your hot dog? You do? Wow. What about 0 toppings? Have you ever just had like a dry dog? Yeah. Yeah. Okay. Oh yeah. Yeah. For a while I was thinking of starting a hot dog business, and I was gonna like have special names like the California dog, had avocado on it, and like Swiss cheese maybe. Yeah, ooh yeah. Anyways, but yeah, I'm still teaching. Anyways, so so let's put some numbers in. So my n and my p, and then I'm going to have this probability of x, box, and then I get a number. So what's my, and I'm reading through here, it says I randomly select 250 people, and I want to know if, what's the probability of exactly 178? So what's my total number of people? Total. 250, you got it. What's my probability? What would I put in the probability box? Not quite. You're close though. Yep. Probability 71%. Yeah. P percent, right? P percent. Yep, you got it. Now this says right here exactly 178. Exactly means equals, right? That doesn't mean more, doesn't mean less, it means equals, and then I put the 178 in there. So that's what I'm going to do in the box in StatCrunch. And let's see what I get. Now, think about it. I got 250 people, and I'm wanting to know what's the probability of literally exactly 178 of those 200 people. It's very tiny. It's not saying more. It's not saying less. It's saying equals. Okay, and then you can see on the little red bar is saying, hey, it's pretty close to average. But it would have to be literally just that number. Nothing more, nothing less. Are y'all okay with putting in the numbers? See how I did that? And just duplicate that 20 times on the homework and you're good, that kind of thing. Let's do it some more. So any questions? Okay, I'm going to keep cruising. The same thing here with this guy. A little bit of reading. So it says annoying habits for drivers. Small poll. Talking on cell phone? Is that annoying to y'all? Other people doing it, Not you. You're fine. You're a good driver. Slow driving in the fast lane? Tailgating? Weaving through traffic? All the above. Now, which of y'all do these things? So we're not going to go there. So I got 6 people, and I'm going to ask them, hey, what's the most annoying thing? And they're saying cell phones, okay? So basically, they're saying just the cell phones. That's the only thing I'm looking at right now. Literally, all these go away right now. I don't care about them. I just want to talk about cell phones, okay? So I got total of 6, 32%. Total of 6, 32%. And they want to find out all these individual probabilities. They're like saying that x equals 0, equals 1, equals 2. And that's what I'm going to do every step of the way. So I put that in. 6, 32 equals 0. So that's going to be my first number they want. Your homework looks just like this. I changed the 0. I don't want 0 anymore. I want what do I put now? A 1. Enter. And I get a new number. And then I change the 1 into a all the way down. You got it. This is your homework. And I did do it ahead of time. I didn't find too much problems with this, honestly. And like the next section is a little interesting at times, but I would say it's much better than it was in the past semesters. When we were using Newton Alta, it was difficult. Now it's been simplified, which is a very good thing for us going forward. Yeah. Yes, we had used this a long time ago. Since I've been here like for 18 years, we had statistics with Pearson a long time ago, and then I'm being recorded. We were told to find low-cost solutions to our classes, and Newton Alta was cheaper, and so we used Newton Alta for a good chunk of years. And now we're saying, hey, we want a good experience instead. Hello. So I wrote up all my numbers. So that's not too bad, right, guys? We good with that? Now they're going to say, what's the probability at 2? Well, don't I already have that? It's right there. Just like that. That was easy. It says more than, greater than, or equal to 5. Now, I mean, I could put that in over here. That's fine. But when it says greater than or equal to 5, 5 and 6 exactly. And I add them up, and I get a number. I do need to be able to add these. I need to get some Desmos out. Let me get Desmos Scientific real quick. So just need to get a calculator for that. And of course, you can use StatCrunch to do it too. I just think it's a little easier just real quick to do this. It's a concept thing. Okay. So not too bad here. Good? So yeah, when they say, hey, more than or equal to 5, then yeah, 5 and 6. That's perfect. Good? Good? Any questions so far? I'm here for you at any moment. Okay? I'm going to scroll then. 5, 4, 3, 2, 1. Awesome. Okay. Oh, look, 64% of people, of pet owners, say their pet is their best friend. Oh, isn't that nice? Is that it's terrible? Talk to me, man. Oh, you have human best friends. So you're part of the 40, the 30, 36%. Do you own pets? Oh, okay. Well, there you go then. We did a statistic. We could talk later after class. You have 10 pet owners. You're going to ask them, is your pet your best friend? Blah, blah, blah. And so let's go back to StatCrunch and put it all in. What's going to be my total that I'm looking at? 10. And what's my probability? Perfect. Perfect, perfect, perfect. So it says exactly 9. Like, what it means exactly, it means equals. So equals 9, put it in, and well, that was it. What I'm gonna do here in the notes, I mean, I know you see it, but I'm gonna write out what I did on StatCrunch so that you can see later. Like, what was that guy doing? Oh yeah. I mean, I know I got the recording, but it would be kind of annoying to have to like dash the recording just to know what did he type in there again. So 0.06485. So that's my answer. Cool. Yeah. Yep. Yep. 64. Oh, this guy. Yes. That stands for probability. Yeah. Yep. The probability of this happening. Yeah. It will be. See how it says at least? So now we're going to finally change it. Yep. Very good on that. Very good. So yeah, at least 7. What does that mean, at least 7? Exactly right. 7 and above, right? So if I did greater than or equal to 7, that should do it. Now, I don't know what they're trying to get at right here. Just I would let that go for a minute. But at least 7, it does it for you. Yeah. See how like the red here, I have my 7 and my 8 and my 9 and my 10. And it goes on past that. They're just showing well, actually, it doesn't go on because it stops at 10. But yeah, greater than or equal to 7. And that was it. Very good. Very good. So yeah, pretty straightforward. Now, what are they trying to say with this whole like the probability is represented by this? I think that they're wanting you to do this thing and then 1 minus that thing. I'm not 100% sure about that, but there you go. At most 3. What would I be putting in the boxes this time? Like 3 is the most, right? So what else could be a possible number? 2, 1, even 0, right? Less than or equal to 3. Like equals 3 is still okay, but yeah, 1, 2, even 0. 0 people think that their pet is their best friend, right? So those are all possibilities. Okay, there we go. Awesome. I think are we getting close to the end here of this section? No, we're at the halfway mark. That's okay. That's okay. Yeah, we're at the halfway mark. Go ahead. Go ahead. Um, so your homework is going to constantly ask these questions here. Well, in 100, different trials, blah blah blah. What would you expect for exactly 9? So exactly 9, if you remember, it was this 0.064 business, 0.06485, and they're now saying out of 100 trials, every time all we do is multiply by that number 100, and we try to get the new number. So I'm gonna pull up Desmos for that one. That is correct. No, that's good. That's good. So you know exactly what's going on. I think that they're going to want a whole number. I'm not entirely sure. But yeah, I would put 6 probably on the homework. But you're right. Just shift it over to. That's perfect. Yeah, if you know how to do that, just do it and no problem. You're good to go. Awesome. Okay. So these are just some like reminders. Fewer, greater, at least, more than, that kind of thing. There you go. You got them. So they're just there. They're just reminders. I didn't really use them. All right, phase 2. And this is like the second half of this section. Although it's still, there's not much left really. They're going to ask for what the mean and the standard deviation in particular are. They're going to ask for these two guys, and it's a formula. That's all it is. Okay. Let me show you how this works. Very straightforward. It's not a big deal. So it says find the mean. It does say the variance, but really it's just going to be those two on your homework. Here we go. So my mean is n times p. I'm literally just multiplying. That's all I'm doing. I get my answer and I'm done. And this is what you would do on the homework. Okay, so I got 50 times a 0.7. There we go, 35 straight up. I'm going to go ahead and do the variance so you can see what's going on here. That's n times p times q. So q is the opposite. So I have 70. So what would be my opposite of the 70? Like 1 minus the 70, what would it be? 0.3, 30. 70, 30, right? 50, 50. 20, 80, yes? So here, got 70, 30. So I'm going to multiply it by that 30 as well. Hold on. Let me do this. Okay. So 50 times the 70 times the 30. There we go. They're never going to ask you for that variance. It never comes up. But the standard deviation is important. What we're going to do now is the square root of all this, the square root of my 10.5. And I'm just doing that in the calculator. 3.24. There's your final answer. Is that okay? Yes. Good idea. All right, cool. Go ahead. Yeah. Oh, I'm here for you. I don't mind pausing and waiting. Whatever you want. The square root of that previous answer. Yep. Yep. Exactly. So yeah, I multiply them all, and then I just say square root it. You could also do it all at once, where you can do it like this. You could even make it more formulaic, where you don't have to actually figure out what that 30 is. So this is more of a formula style, where I got my number, and then always just 1 minus the number. And every time it'll work for you without any problems. Cool. Yeah. That's definitely a quicker way to do it. Awesome. Okay. So next, 17% of people in a city donate blood. They're going to pick 4 people at random. What's the probability of all of them, none of them, some of them giving blood? So you can see that they got N and P already set up. Back to StatCrunch. Right? And so I'm going to say equals, and I start with a 0, because they say start with a 0, we start with a 0. And one by one, just start filling in the table here. Is this okay for y'all? Are y'all okay doing this? Okay. Thank you. Thank you. No, that's good. That's good. Yeah, that's good. I just don't like hanging on like a bunch of silence, just like I'm doing all this stuff and you're just yeah, yeah, acknowledge it, yeah. I like it though. It's good. It's good. Yeah, acknowledge. I do that with my wife because like she can't hear very well, and so sometimes I say something and I'm like, "Did you hear it?" And I say acknowledge, and she'll tell me. Yeah, exactly. Repeat it back. Yep. Very good. So pretty easy though, right? Pretty easy to put that all in. I know it's like one by one, but it does work. It's pretty straightforward. Now they say which of these would be a cool graph for that? We don't have to go clicking on stuff in StatCrunch. I mean, I guess you could look at it right here. There's your graph kinda. But you can also look 47, 38, 11, 1, nearly 0. C. You got it. Just looking at the numbers, looking at the little kind of bar graphy thing, line graph. I don't know. Pretty straightforward. And skewed left or right? Skewed on the right side over here. Very good. Yep, skewed right. Perfect. Awesome. Good to go? Straightforward? Keep cruising then, okay? Yeah. Oh, okay, yeah. Good. Acknowledge, right? It says find the mean, variance, and standard deviation. Okay, so I thought we were done, but we're not. They want to keep going. And I don't know if y'all have done the homework recently, but does that ever feel like that on the homework? It's like, hey, part 3 of 7. No? Oh, yes, indeed. Yeah. I don't find that in pre-cal so much, but definitely statistics. So yeah, my mean, I'm going to just multiply these. So 4 times all this stuff. Definitely pull up the calculator for this one. Okay, so 4 times 17 there. Sweet. So that's the average. That's not a percentage. That's like people. That's like people who donate. On average, you get 0.68 people who will donate blood or whatever it is. My variance, 4 times the 17. And what's opposite of the 17? $83. Opposite of the. It's all good. You know how many times I've messed up doing this homework? I was upstairs doing it right before class. Not this one, but another one. Oh, times, yeah. Oh, the 68. Yeah, I see. Yep. I totally understand. Um, as I'm writing this last one here, I'm going to do the square root of that. It's the square root of 5, 6, 4, 4. I work on projects at the house, and I I flipped 2 numbers around in my code, and somehow it worked. Like I had like a 1, 2, 3, 4. I said 1, 3, 2, 4, and it was like it somehow just worked. And I was like, oh my gosh! And I didn't know that I had flipped it. I just went back and looked at it. So then I was like, oh, well now that works. Let me try it somewhere else, and it works every time for everything. So yeah, dyslexia works. I know, like I'd have to show you and explain it, but it's just silly. Like I made a mistake, and it actually helped me get the right answer in the end. Yeah. So it says on average, that's my mean, and that would be that 0.68 business, or maybe you would do a 1 on the homework if it says like a whole number, Standard deviation, 0.7513, and it says it would be unusual for more than blank out of 4. Okay, now let's time out for a second. The unusual is supposed to be 2 standard deviations away. You have to have a formula for this. So let me give you that formula, okay, on how to do this, and then I'm going to do it with you, okay? So the formula is mu plus 2 times sigma. Now that means very little because it's all Greek, right? It's all Greek. What it is the mean plus 2 times my standard deviation. And that's what I'm going to do. My 0.68, let me try that again. Okay, here we go. The mean, and then that's 2 times standard deviation. Yep. 0.7513. So let me put this in right quick in the calculator, and I'll show you. On your homework, you will have this question come up. And so, like, what do you do when you see this problem? You do exactly what I'm showing you here. 2.1826, that's the answer that they're wanting. Of course, like round or not round, whatever they're wanting. But I specifically gave you this weird, funky Greek formula because that's also on the homework. There's going to be a question on the homework that says, well, what's the formula for blah, blah, blah unusual? And you're just going to click this button and you're done. You don't have to type it. It's multiple choice. You click that button and you're done, okay? So I'm just warning you ahead of time. They're going to ask for that weird formula. Oh my gosh, look, part E, part F. All right. We can do this. Using binomial calculator, what happens when we change all these numbers? Okay, so let me pull it back up. This is more of a concept thing. So they're saying change my P to a 0.3 and then a 0.4. And look at these bars here. Let's do a 0.5. You see the 0.5 already? What is this looking like now? Yeah, it's a bell curve. Exactly. 0.6, 0.7. Exactly. It keeps shifting over until it's now skewed left, right? Left. Correct. Okay, that was a funny little joke. Anyways, so when the value of P nears the value of 1 is what I put, then it becomes skewed left. Okay, it's multiple choice on your homework. You click it, you get it. It's not that big of a deal, and you only have to do it like one time maybe. It is. Yes. That is, yes, 2 times. Yes. You got it. That's a 2 times. Just a regular. Yep, with a plus. That's right. That's a plus. You got it. Yeah, let me go back to the calculator right quick so you can see it. See? So I got that plus and then 2 times. Very good. Very good. Yeah, my times are a little weird. And then it says, we'll go back and now put it in with bigger numbers. What was my P anyways? 17? Okay. So now they're saying change it to 10, 20, 30, 40. What's happening to this curve? Yeah. Yeah, it's changing, right? But it seems like the more I got here, let's do a 100. Let's do 1,000. What is? Yeah, it's a bell curve. Exactly. It says as n increases, the shape becomes more bell curve. I think they're going to want the word symmetric. Yeah, but yeah, definitely bell curve for sure. Definitely a bell curve. I did not even know what to put in here. I don't have a good answer for you. I didn't actually answer it, and I was okay on the homework, so whatever. But I do have some stuff I need to put down here. Okay, there's a lot of little notes on the homework. Okay, so this is on the homework, little notes that I have to give you. Okay, we might need to use the between feature on your binomial calculator, and I'm going to show you that like real quick. It's so easy, but I just want to this is a reminder thing. Okay, see up here at the top, it has standard and between, and so what they're basically, standard is just like pick a number, any number kind of thing. Well, between is between two numbers, and so I'm just going to do the one that we have here. What if I did like 30, or let's do 300 all the way to like 700? This is not going to show. It's not going to show. Let me bring it back down. Let's go 3 to 7. Okay, let's go even like 6. Okay, that's good enough. See how I'm going from this number to that number, and it's gonna only put the red on some of these guys. If I did like 3 to 5, then you can't see it. I'm so sorry. I'm gonna try to. Okay, there. There's only the 2 that are red, and then it turns black again because I'm not using it. So this is just another way to use it. Not super required, but I think it's faster in some cases. All right, I got 2 more things. On number 8 on the homework, specifically number 8, it's going to use the language fewer than half. It'll say that on the homework, and we're supposed to use this symbol right here. Now, I've got to say, I have no idea. And I have question marks on it. I'm very confused, but I did that and it worked. So when we get to the homework, maybe you can tell me what's going on because I don't know. And then finally, number 10 on the homework, we're going to have to use sliders. And I just put dots because apparently that would make me sad. So we'll see it here in a second. It says greater than actually. And that's the thing. That's why I was confused. Fewer than half. Why is it bigger, greater? That's a greater than symbol technically. Yeah. Because it says like this number is greater than the one on the side here. Just use that symbol. Yeah, it's kind of weird. And then number 10, we're gonna have sliders. And so I think that's it for that. I want to go up to the homework, and I just want to cruise around, and especially this number 8, number 10, for sure. Are y'all okay so far? Cool. Number 10 is sliders. I can't remember why I wrote that, but apparently it made me sad. So we're gonna go and look at why I was sad there. Okay, here we go. Like got rid of my homework. Okay, here we go. Okay, so it says which of these criteria apply for binomial? Boom. You remember on the workbook how there was like those questions at the the things at the very beginning I totally skipped over. Let me go back, and back, and all the way back. Right here, these guys, those are the ones you're clicking. Just find them and click them. So probability of success is fixed number of times, independent. Probability of success the same. 2 mutually exclusives. There. 1, 2, 3, and 4. So I mean, it's just a copy paste of what the workbook had. I'm not worried about it. I just wanted to remind you that's on there. Is that cool? Keep cruising. See how they're asking what success is and all that stuff? So binomial experiment is done this. Repetition. Binomial experiment performed fixed number of times. Each repetition is called a what? I don't know. Trial? Okay. Oh, here. So in binomial land, I mean, wouldn't you have left, right? Yes, no? Over, under? Cheese? No cheese? Right? That makes all sense. But what is the book saying? What is the homework wanting? It wants success failure. See how I was like talking about that? I mentioned that, didn't I? Didn't I mention that? I did the homework. I did. Okay, I'm not worried about these guys. There's got to be something else. Let's keep cruising. Something else. Okay. Right here. So they have 12.4 and 3. Here we go. 12.4, and then back to standard here. I'm going to say equals a 3. 1, 9. Sweet. That's pretty straightforward, right? Type it in, get a number, done. Any questions on that? I'm gonna keep rocking and rolling. Okay, let's see what else we got. Same thing. Not worried about it. Whoa, that's a whole bunch of words there, Chad. Well, let's go through it then. Oh man, look at this again. Look, I told you it'd come up again. Fixed number, same, 2 mutually exclusive, no, independent. Okay, what's my n? So they're wow, this is so tiny. I'm gonna try here. Okay. What's my n? So they're looking for the total number of flights. 25. Let's try it. Oh, look, isn't this what? Look, part 3 of 11. Don't you? Isn't that awesome? P, what's my probability? 80. They're going to ask for what's the They didn't ask for what's the opposite. They're saying exactly 16. Well, that's back to what we're doing over here now. So 25.80. And then it says exactly 16. Putting it in. 294. So copy paste from StatCrunch. Is that okay? Pretty straightforward there. No problem. Just put it in a StatCrunch. Out of 100 trials, what would you expect? Well, if I move the decimal place twice, I get 2.9. If I round it up to a whole number, what would it be? 2.9 is 3. Yep, you got it. It's 3. Yep. So, or you can use a calculator, obviously. Say times 100. Fewer than 16. Here we go. Less than 16. 17. Oh, 0173. Okay, sweet. So that was my answer. It says times 100. I shifted over twice. 1.7 would round to what? 1.7. 2. Greater than or equal to 16. We got a number. 9827. And so if I take 98 and I shift it 2 decimal places, I get 98. Wow. Now it says between. Okay, now hold on. There's a button for that, right? See up the top it says between? Okay, I'm coming. What you got? Oh, like what question I'm on? Let's see. I'm on number 7. So it says using binomial, what's between 14 and 16? So between, I click between, and then I put in a 14, and I put in a 16. 4, 5, 2. Yeah. It says, hey, if I shift it over 2 times, what's my whole number if I shift that over 2 times? What's my whole number? Shift it over twice? 4.5, yep. So